This is a Bilco unit where the stairs are solid poured concrete, and they're actually bolted to a rock wall, a stone wall, an 1800s rubble foundation. And it's very problematic where the concrete meets the rubble. In this case, there's a bit of rough-hewn trim. So we've cleaned and epoxied this seam. We've also used a urethane injection in the seam to fill the voids with an expanding urethane. And that fills in the voids in the soil where the water would normally pocket, and the epoxy seal just seals everything up nice and tight. We've done that on both sides. So this was all cleaned up, tuck pointed, and then urethaned and epoxied, and we actually drilled through, and we insert ports and then inject under pressure the urethane. And what the urethane does when it comes into contact with water is it expands, and that urethane also repels water. So it fills in the void and remains a little bit flexible. So what's good about the flexibility is this Bilco unit will pick up and set down just a little bit as it freezes and thaws during the normal freeze-thaw cycle of the year, because there's no weight on top of it. So part of the stair is necessarily above the frost line, so the ground will expand when it freezes. The urethane will remain pliable in that fracture and will continue to keep water from penetrating. But in the event that the steel doors leak, or the seam where the top of the cover is attached to the wall, which has also been cleaned up and epoxied, but if that moves or leaks, we've got that interior drain as the last defense to collect any water, any errant water that might end up coming in. So we've used urethane injection, we've actually done bentonite injection on the outside, we've used a mechanical repair, and then the epoxy, and then we've got a drainage system. It's a whole multi-step approach where not one item would fix this problem. It's a multi-step approach that gives us the measurable effects we're looking for.